Today, welcome to WebHack. Today, our topic is types are eating the world, and it's presented by Daisuke Shimamoto. And this is our schedule. I will first doing some quick introduction, and then Daisuke-san will talk about types are eating the world, the main topic, for 40 minutes. And we have another 15 minutes for Q&A and another 30 minutes for networking. And considering we don't have too much attendees today, we can have more casual networking talk and talking about like type theory or Haskell. And let me quickly introduce WebHack for those newcomers. It's a tech meetup in Tokyo. And we've been hosting this event for over 3 years. And we invite speakers from different fields talking about tech topic every month. We used to host this event in different offices, but during pandemic, we started moving every event online. And we even have our own YouTube channel right now. If you're interested, feel free to subscribe to WebHack Meetup. You can find our previous videos as well. So far we have more than 1,400 members, and it's keep changing every time I made these slides. And we have more than 1,800 attendances since we started hosting this event. So if you like to become a speaker next time, you can check this URL. Can somebody help me to put this URL in the chat? And yeah, you can sign in and just tell us the draft of your topics. And yeah, we will review your proposal, and then you can talk in WebHack. And we do the collaborative notes every time. This is our link. So some of you, can you help me to press the link to the chat as well? And without further ado, let me introduce Daisuke Shimamoto, to our today's speaker. And he's now engineering manager at ProGrid. Yeah, Daisuke-san, please take it away. You can share your screen. Welcome to the stage. Let me stop share.
Hope everyone can hear me. Let me share my screen. Hold on, just realized that I had updated Zoom and it does not have permission to share my screen right now. Give me 1 minute.
All right.
Sorry about that.
Yeah, no worries, take your time.
I might need to log in and log back in. If you give me 1 minute to actually do that.
Yeah, go ahead.
Apologies. Okay, sorry about that. I'm back in, and so let me
Cool.
share my screen. There we go. Can you see the slides okay? Okay.
Yeah, pretty good.
Quickly begin. So my talk will be about types. First of all, just about myself to begin with. My name is Daisuke. It's pronounced Daisuke. just in case you're not from Japan, you've never seen this name before. My Twitter, LinkedIn, Facebook, etc. My ID is right there, this Kashima. And I'm currently an engineering manager at ProGrid. ProGrid is an English coaching company, so we teach English to people in Japan. My past experience includes working for a US investment bank, especially during financial crisis. I was using Java and Spring, also C# and .NET. After that, I did some startup jobs that I mainly using Ruby on Rails, React.js, React Native, etc. Me and Mike about types. I am fascinated by types in programming. I just find them interesting, and I write Haskell as a hobby. But I'm not using it today, so please don't run away. Before we start, again, my talk will be mainly in TypeScript and Swift, just so that people can kind of intuitively, even though they may not use language before, get a sense of what I'm trying to convey. It has good support for types, I think, especially in the mainstream languages, among mainstream languages. But again, I won't be covering type theory itself, or like monads, or some of these weird Greek symbols. Like, I don't even know how to read all these, alpha, beta, gamma. I forgot what the rest was. So again, please don't run away. The key takeaway from my talk today is that types are becoming more and more important, and I would like to show what kind of things may come in near future. Obviously, you might ask why types are becoming more important. The reasons I think are because software that we are creating every day is becoming more and more advanced and larger, more lines of code, etc. And obviously more and more complex, which obviously leads to more bugs. So what can we do? And we can't just be fixing bugs every day. We want to do interesting things, not just fixing bugs. I think the answer is types, obviously, as people might have expected. Just to start with some basics when I say types, these things like ints, floats, chars, strings. Again, this is in various languages call it various ways, but I guess some people will understand what these are. One's ints, one's named characters, IDs, etc., etc. And some a bit more advanced ones would include things like function types. So here is a good TypeScript language where f is a function that takes in a number and then returns a string. So the function n here will be a number, and you do something the n and then return a string. And also another example would be like generics. I'm pretty sure if you've used languages like Java or C# or TypeScript, you've seen these where you can kind of place a hole in the language saying that this will be filled in with some other type and make a generic function that will support arrays of ints or arrays of strings or whatever you want. But these you might have used in your day-to-day jobs or in your languages that you use every day. But types, I think, can do much more, and they can actually do much more. So let's look at some fairly new and advanced types. One would be like optional. People who use languages like, I guess, Scala or some recent Java might already know about these. It basically tries to prevent these things in the middle, like Java, lang, or point exception. If you use Java, I'm pretty sure you've definitely seen these, and I think it's one of the most common errors that you see. And also, like this type error thing is mainly from JavaScript. Undefined is non-object. I think I was talking with Greg just before the talk saying that we don't want to see these anymore in the language. And so optional is a way to prevent this. Some quick example in Swift. If you say, let's say you've called a function that may return a nil, and then you would insert this into an optional int. And after that, you can take out the int inside the optional, which is it's like here, and then you're assured that the a here will be not an int, so you won't get the error. And on the other hand, you will need to provide what you want to do if it was nil here. But the key point is that the compiler can check that you have done your job and check for the null right here. So again, just to repeat myself, the compiler can check that you've actually handled the case of nil, and that's, I think, is the most powerful and very important things about an optional. Java calls it optional, C# calls it nullable. I think Kotlin calls it nullable, and you might have seen it in your language as well. A fun fact about null, the null, just to derail a bit, null was first introduced by Tony Hoare, a famous computer scientist, and he introduced it, but then later called it as the billion-dollar mistake, saying that I call it my billion-dollar mistake. It was the invention of the null reference. Kind of fun thing back to know. And this plagued us, all engineers after that. Another example I would like to give is async await future promise. Various languages have it different support, or they call it different ways, but I think it's come to be a fairly new concept in programming that's helped us a lot. And this way it handles asynchronous executions. That's the async await stage right here. So for like example in TypeScript, it's a kind of a bit of a long example here. But let's say you've got a function that prints out the message that you gave after a given delay. Right here, console.log. And when you write console.log first, and then you pass hello to delay print, and then you call another console.log, and then delay print hello to, etc. And the key point here is the order that this will actually be displayed. So intuitively, if you just read it from top to bottom, it might look like you're first printing this dispatching, first delay print, and then hello, and then the second one, and then hello 2, and the third one, and hello 3. But because of the sync wait here, what it can do is you can actually specify which one you want to wait for and which ones you don't want to wait for. So the first one you haven't waited for, so the hello comes after this second delay print. Whereas the third one right here, these two sets, you've actually specified the wait here. So it will wait for this to be done, and then it will print out the third hello right here. So it's a way to express a synchronous execution and try to get control of it. And I think I found it very intuitive compared to like the callback hell that some of you might have seen if you've used JavaScript before without these promise async await style of programming. And interestingly, it's supported by C#, TypeScript, Kotlin, JavaScript. I think it already has it. I forgot if it was really yet, but TypeScript does. And also it's gradually coming into other languages. So like Swift has just added it recently, and also C++, I believe, has a proposal to add it in the near future. And it just tells how much the engineers like this feature. So quick summary, this was kind of the first half of the talk. I think types are eating the world, as my title says. And advances in programming languages are speeding up like crazy. If you know the old days, it used to be much slower. Like Perl 6 or C++, 0x. They took a long time to get introduced, but it's much faster these days. And things like Babel is like a transpiler in JavaScript, and it has helped a lot in kind of making progress in all these languages. But types I think, can do even more. And this is kind of the main part of my talk. So let's look at some more advanced types that we may see in the future. No guarantees. These are kind of interesting types that may come. I find them very interesting and also very useful, although a bit complex. So I will not make guarantees that they will be introduced in mainstream languages, but I think I find them interesting, and so I think it's very good to know when they, just in case when they're actually being introduced to languages that you may use. The first one is algebraic data types. Algebraic data, sorry, this one's a difficult one to pronounce, to be honest. Algebraic data types. It represents relationships between data, and there's two kinds. Interesting, some people call just the sum types algebraic data types, but I think the proper definition is that it's the sum type and the product type right here. these are just words. I'll be giving some example words in the slides. And the first one is the sum type. The data could be one of type A, or type C. Also type A, type B, or type C. And the other one is product types. It means that the data will hold an element of A and an element of B and whatever you would specify. They are also called structs or records depending on the language that you use. An example of type of a sum type in TypeScript would be, let's say, the interface here, you can think of it just saying type. So this interface A introduces a type A, and B introduces a type B. And then you can say A or B, meaning this A or B type will be either an A or either B. And also a quick example of a product type is this one's not very difficult. It's just a struct that holds one type of flow and then another type of flow. We can obviously have other ones like type let's see, or string, etc., etc. Also, now you might think how or where you will be using these. The first use case of a sum type, if again I'm giving an example in TypeScript, is, for example, you want to define the type called shape, which you want either be a square or either be a rectangle. So for the square example, you would have like size, whereas a rectangle, you would need the height, width, and height of the rectangle. And so the type shape, the sum type here, says that the variable of shape will either be a square or a rectangle. So what now? Obviously, how this could be useful is that the first example is a non-exhaustive type. So this function here takes in a type of shape. Again, this could be a square or a rectangle. And then you can do a switch case statement on that type. And then say if it is a case square, and then you can return the size double. I can use this S as a square type inside this case. And so this part is not very intuitive, but you can see that I have not handled the case of a rectangle, which obviously I gave in the previous slide that this could be a rectangle or a square. And when you've not handled the case of rectangle, in TypeScript, this is kind of a weird syntax in TypeScript, but here you would try to, because you have not handled the case of rectangle, this will try to map itself to another type, which the compiler will complain at compile time. So this is in this way, you can be assured that you will not introduce this bug in your production code, because the compiler will check that you've actually handled the case of rectangles here. Another use case is that if you try to use it in another way that you're not expecting, that you've not specified as type. So for example, you've handled the case of square, you've handled the case of rectangle, or for some weird case, you've tried to do it on another case. And again, here, the compiler knows that the shape can only be a square or rectangle. So if you try to pass in something else, it'll complain at compile time instead of runtime. Obvious? I guess yes. It's very intuitive in that sense. But interesting, some mainstream languages actually do not have support for this. So for like a PHP, I program we use PHP on our server side, but this doesn't have in some types of product types. I guess a class could be considered like the product type, but it doesn't have proper support for it. They do have a proposal for unstructured data types. And also for Kotlin, which again is a fairly new mainstream language, does not actually do the compile time check exhaustiveness, so the one that I gave previously about this bit. So it has like proper handling of like support field classes, and you can do switch case statements on the types, but it does not have exhaustive checks yet, and that's being introduced now. So interesting, as intuitive as these things may seem, some languages don't actually support it yet. So you might wonder why they're called algebraic data types. Again, I wanted to keep this slide very simple, so I won't go too much in details here. It's something to do with the math behind how many things can actually be handled in type. I recommend reading this blog post called Algebraic Data Types, where it shows how maths fit into these types. It's very interesting. It's very complex, I guess, but once you get it, it's very, very interesting. And the second one is dependent types. All types so far have made a clear distinction between types and values, and also values depend on their types. So, for example, the num here is int, so it can only pass in one, meaning that the value that you pass your setting to a variable depends on the type int. And the same thing for this str of type string. You're passing hello, which obviously has to be string because you've said that it's a string. But can we not just kind of flip this, i.e., as types depend on the values? It's like, what the heck? Okay, I know this slide did not make any sense. Types depend on values. So let's start with the problem that we want to solve, just to ease the understanding. The problem that a simple problem that is a function that expects an even number. So let's try writing this in simple TypeScript. It won't be that different in things like JavaScript. So let's say if I were to write this function, I guess I would check that the input of n is even by taking a remainder and making sure that it's not 0. Sorry, making sure that it is 0. So if it's not 0, then just, I guess, throw an exception or something, saying that n is not even. And in the else case, you can handle it as an even number. The unfortunate bit, I guess this works, and it's one way to implement it. But the unfortunate thing here is that the compiler will be totally happy with this, because you specify int, and you've obviously passed in like 1, which is an int. It's fine, but the human, if you read this code here, you can quickly tell that if there was an error here. The compiler will be happy, there will be definitely an error. So one way to handle this is dependent types. So dependent types allow you to use the values in the type itself. Okay, it takes some to sink for this to sink into people's mind. I've kind of made up a syntax for this right here. It doesn't actually work. It's copied from another language that does actually have dependent types. And kind of try to mix it into TypeScript. So it might look weird, but I'll try to explain it as much as possible. The function f takes an n, and it has the type specifier saying that's an int, as the previous example. But you can also specify kind of the condition of what that value should be. So here you could say n, the remainder of 2 will be 0, and this will be done at compile time. So the compiler, if it was passing 1 to this function, can actually do the check against this condition and give an error at compile time instead of runtime. So again, it was a very quick example, but I think you can kind of see the power behind this, that you're adding more logic into the types, and thus it does more compile time checks versus runtime checks. So here again, it's just to repeat myself, you've added the logic here instead of doing it at runtime like in the previous slide right here, where you're doing it at runtime. I guess this is kind of the usual way you would do it in languages that do not have dependent types. But once you're able to encode the logic in the types, you can do much more compile time checks. A user on Stack Overflow will refer to as dependent type enable logic set logic errors to the remains at compile time. And I guess if I'm repeating myself, I found it a very succinct and clear message that the more you can do in the types, the more a compiler can do instead of humans doing the check or the users actually seeing it as a production error. Unfortunately, the unfortunate thing about dependent types is that not many languages support it yet. So one example is Agda, and another one's Idris. I'm pretty sure not many people have heard of these. Very interesting languages. Personally, I haven't used it much. I only kind of done like the introduction examples. It's very interesting, but at the same time, it's very complex. So I wouldn't expect people to be using these in your day-to-day jobs. But the concept of dependent types is very interesting. I think it's very useful. So we just have to wait and see if the mainstream languages adopt it. The third and kind of last one that I would like to introduce is linear types. Linear types, again, the name doesn't kind of convey what they are very well. So again, let's start with some problem that we want to solve. So the problem that we want to solve is how can we prevent use of variables when they should not be used? By that, I mean, for example, if you use languages that where you have to allocate your memory yourself, it's a very common error to make. Try to use a variable that you already feed the memory for, which obviously leads into an error. Your program will most likely crash. And also, people tend to forget, or they may have freed the memory already, but they may try to free again, which is not what you want to do. And also, these are kind of C++ or languages that you use, you allocate your memory yourself. But another typical example may be accessing a closed file handler, or maybe like a network connection where you've already limited the close, but you try to use it again. Obviously, that will not work. So linear types is a way to actually prevent this. Linear types makes a very strong limitation what you can do with types. Specifically, linear types, you can only use the variable once, and you have to use the variable once. The key here is that it's a must and once. Use case is again just like the file handler example. The people using linear types call it linear resources. So again, I've made up some syntax here, which actually doesn't work in TypeScript or any language, just to convey the idea here. So let's say we define a linear function called readFile, which takes in the file path of the file you want to read and returns the content as a string. So when you try to open it, again, this is all made up, so but I hope I get the point across here. So you try to open the file here, and you get the file handle, and then you read from the file, and this is the use once bit, and then you're not allowed to use it right here, and you get the content out of the file and then return the content. And the interesting thing here is that because you specify that this is going to be linear, the compiler, even though you forgot to close the file handle here, the compiler knows that the file handle will not be used anymore, so it can emit like an operation to close the handle, or maybe close the network socket, etc. And so again, without you actually having to remember to close or free your memory, etc., to the resource, etc., the compiler can actually handle this automatically. Another use case is on performance. So again, linear types give a strong limitation or guarantee that you will not be using your variable that you use once. So what the compiler may do, I'm not saying that all the linear type compilers do this, but what they could do is, for example, if you've passed in a string to a function and you've added it with str2 and then returned it here, many common mainstream languages actually allocate a new memory for str2 in addition to the str you already passed in, and then return the new allocation here. But the compiler can make a decision that to overwrite str right here instead of allocating new pieces for str2, because you guarantee that you're only using it once. So get this again, something that you can help the compiler make better decisions by specifying a function as a linear type. I'm sorry, I was kind of quick talk, but some So to summarize, some recent types, I've introduced some recent types in mainstream languages like optional and awaits and feature and promises. And also I've introduced some more advanced types about algebraic data types, dependent types, linear types. I hope it was kind of interesting, and I hope you kind of decide or think that it might be worth looking into and seeing if it enters your mainstream languages that you use today. Okay, thanks. That's all from me.
Thank you. It's a pretty interesting talk. I'm like pretty impressed by the introduction of dependent type and linear type. I have a bunch of questions I want to ask you, but let me leave it for the audience first. Anyone have any questions? You can like raise your hand, or you can just jump into the stage, whatever you want. No one?
I think there's one, right?
Oh yeah.
Sorry. Hi. Thanks for the talk. One question: can linear types and dependent types be used together, or they are orthogonal logics that can't be used together?
I believe they can be. Interesting that I have not seen an example or language that does this, but theory-wise, there's no reason that they can't be. Maybe it's because I haven't like looked into it in details or actually used it myself on day-to-day, so maybe I haven't had a case like that, but I'm pretty sure they can use it at the same time.
If I can reply to that question. So actually, Idris 2, which is new version of Idris, implements something which is called quantitative type theory, which idea is very close to the linear types, as you showed. And in this quantitative type theory, you can specify 3 cases how the variables are used. But if you specify like 0, it's like just on compile time. If you specify 1, it is used only once. Or you can have the third option, which is unrestricted, which is like, say, I don't care how many times it's used. So it's very similar to the linear type. So maybe that's sort of, yeah.
I guess it's kind of similar to what Rust does, I guess. I think Rust, I think it's a fine type where you can use it many times, or maybe not. Oh, actually, no, it's only, oh, sorry, it's different, isn't it? Where a fine type to say you can't, you might just not use it.
Sorry, one more question. What is the difference between, is there a fundamental difference between dependent types and refinement types? Like I think liquid Haskell is one example.
I haven't looked into refinement types enough to actually say it. Sorry, I would need to look up myself to see if there's a fundamental difference there.
Any other questions? I can ask you a question. I also have one. I'm wondering, one of your slides mentioning the example of linear type, and you said the compiler can know you haven't closed a file, right? I'm wondering how the compiler deduce these kind of things. What's the type of the file handler? How can compiler knows you haven't closed it?
The compiler, because you have
yeah,
oh, go ahead, sorry.
And then I bet probably like file handler must have some certain type which can give the compiler some hint. I'm wondering like what kind of hint did they give it to the compiler?
So I guess the file handler would also need to encode that it's linear in that. Yeah, so it's not, I guess you cannot use it with some random any file handler type. I think the 500 they will need to know that it's linear as well. If that's answered your question.
I see, I see. Interesting. All right, any other questions?
I think there will be a question for why, how can these things become realistic for business programming? Because usually when you talk about dependent type, it's become people start to have daydream and find no use case. But actually the first two, I think, usually the easy demo case, one is for null pointer exception. Every time if you spend some time to debug and find out there's actually a null when it should be something like API result or like a file, and you got the problem, the language doesn't support you with a proper type system, so you need to debug by yourself. And sometimes it becomes nasty because our test cannot catch such a little null. And another good example is when you talk about dependent type, usually the most useful case is you can check how long the array is. It's very difficult if you don't have dependent type because you need to always remember to do the runtime check. And even you remember to do the runtime check, if the API spec change and you forget to change one part of that, then you are done. But I think optional is relatively easier to implement because dependent type require you to totally change what the value is and what the type is from a fundamental part. So that's why even Haskell is struggling to get this done. Although behind the Haskell struggling reason is because the community that got some problem there. I remember last time I heard about the dependent type progress in Haskell is because there's only one who is trying to put this as his PhD thesis. So progress is slow. But anyway, I think that at least we now have optional in mainstream language. And I think one day maybe they will realize this is also necessary. It's usually like 30 years later from the academic result. So I don't get surprised it didn't take long to get it done. But anyway, these are two things actually every day in business programming, you face them, you debug. So that's a real example. Yeah.
Yeah, I also think it's kind of time because we're developing software and softwares don't die easily. So we have a large code base of old code. And because we're doing more and more coding every day, there's more and more code that's being generated. And then I think from business side perspective, people can start to see that without these kind of upfront investment in types or the time, or the investment time-wise in learning these and using these language features, you'll be wasting a lot of money later on with like everyone handling errors, debugging every day. So that I think is a huge aspect. But having said that, about dependent types, I used to be in a lab that does programming languages, and they were talking about dependent types like 20 years ago. And it's only now that we're trying to start to see in languages like Haskell. So I think the 30 years that you just said might actually be realistic.
It's quite safe that need to wait long, but sometimes I start think this is a good way to keep a GDP and the people have a job. Yeah, so let's see. Yeah, and definitely it's a very, I mean, even Promise actually you demo it as a good way to introduce typing effects. You can generalize this topic because everything about effects should be typeable. You should be able to design a type for I will read, I will write, and the compiler will check all that factors for you. But well, again, mainstream language they're still struggling with problems already solved. Yeah. But I not really feel like hectic or feel why they are moving so slow. I understand the major priority is to keep a compatibility and keep something useful can be released even for the old machines and old program 20 years ago. So yeah.
I'm wondering for other audiences, if the languages you're using doesn't have, for example, optional maybe or other ways to protect you from like null pointer exception, or like undefined is not an object. Like how do you guys deal with those kind of things? Anyone want to share? Hey,
Still using that. Oh, sorry, someone want to say something? Sorry.
No, I just wondering, like, what's SciFis' opinion on this? He's also a learner of Idris, by the way. Is it? You are, right?
Yes, I'm still an Idris beginner. I mean, I have an experience to use a library called FPTS when I work on TypeScript projects. And I think the library encode the types pretty well so that I can use some types like option or either or some other fancy types in Haskell. But I mean, even I can use that to make the, yes, this one. And even I can use this library to encode the types better. I still feel the syntax is a bit tedious comparing to Haskell, because I mean the Haskell, the language itself can already helps you to encode the type better. So I really wish someday we can write better, we can encode our types better in the future in TypeScript. Yes.
Nice.
Thank you.
What stopped us? I mean, what stopped the community from doing so? Like, make the TypeScript like more friendly, like Haskell. What do you guys think?
Arguments. I believe it's an argument. We don't need this. We don't need that. We don't take this risk. Why you need this? I speak of this because I was a full-time developer as another open source community. I know these things get thirsty. So it's difficult to push some new things just because you try to be friendly to other users. Sometimes some people ask why you need this, and suddenly it's silent, and keep it for like 2 years and longer, no new feature for this part. But anyway, I think to be serious, I think TypeScript has their own goal since the beginning. It's like Kotlin has their own goal since the beginning. So it's very hard to try to say, oh, okay, we may try another domain or another community is a good idea. So I think that's one reason, but sometimes it's just because people. You cannot type people, you cannot make people reasoning easily.
Right.
Programming is easier. Yeah. But just most of just joking, but some experiences are really true. So yeah.
It looks like today we have many like functional programming lover or type theory lover here. Anyone else want to share your opinion? Like we already jumped to the Q&A and networking time. So yeah. And also before you leave, please fill in the survey. I just passed it in the chat.
So actually, recently I'm learning embedded Rust. I think it's a pretty interesting. I mean, Rust itself is from C++. It's not really from like Haskell is an academic language people usually to criticize like that. But Rust actually empower you to write a very low level things like in embedded Rust, you don't have an operating system, you don't have heap memory. You need to manipulate the hardware in safe way, which seems like you need to ignite a file with with water. Hardware by design is not safe if you think about that from the software world. But at least the Rust community try to do things better compared to just get pointers and drew arrows everywhere and panic everywhere actually because you cannot do. So I think Rust is also the first business level example of how you ensure the results get. I mean, it's not linear type. I know people get a very, how can I say, very strong arguments about whether Rust really implement the linear type, and the answer usually is no. But that doesn't matter. I mean, it shows how type system can help you even in such low level programming style. It's a very good example to support that type system really helps, because sometimes people just hate the type system in like old languages. They say, why you need to write in integer equal to another integer? That's usually because the compiler doesn't be smart enough. But I think in Rust, I find that that's a really good example. And even in Haskell, actually, people have the assembly Haskell. It's actually very delicate example to show you can use Monad to ensure some basic rules when you're writing assembly or writing even hardware. There's a hardware language implementing Haskell. So yeah, I mean, sometimes we better to find some real examples that are really useful even for hardware or low-level programming language. It's not really like, okay, I have a paper to write, so I use Haskell. That's all. Yeah.
I see. Yeah, one of our audience, like Merrick Labels, you're also playing around with TypeScript and Idris, right? Do you want to share your experience with them?
Well, I wrote one project in TypeScript, which seems to be working well, and I especially appreciate when getting to the project after time, the types usually help me to prevent such basic mistakes. So yeah, but I also love the freedom of Ruby, which I have sometimes like schizophrenic thoughts, because yeah, I appreciate how free and it's Ruby, but also sometimes I'm very lucky when in TypeScript the compiler finds the errors which I would miss, and I played a little bit with Idris some time ago, and the trouble is that it's still a research project, so it's pretty unstable, and the tooling it's not up to date. So that's I'm looking forward to once the Idris will be more stable and the tooling will be better. So yeah, it's fun stuff to play with, definitely. And one benefit of Idris, which is cool, is that once you give more information to the compiler can actually generate the code for you. So it's very like magic sometimes. Like the author of Idris, has very nice demos where you just specify type of function and the compiler writes the function for you, which is pretty cool and maybe future of the programming.
I'm really there are like few pure functional programming out there. And why did you choose Idris?
For me, it was just lucky accident. I got it through a friend who actually worked on the implementation of Idris. So I just lucky coincidence got to Idris.
Cool.
I'm interested in how Marek thinks about the RBS stuff, the Ruby type hinting type database thing. I haven't used it myself, so if anybody's used it, I'll be interested to hear what they think. RBS, I think it's called.
Yeah, I heard about it, but haven't used that yet. And to me, it feels a bit strange that, well, the benefits of Idris is that it's built in mind with dependent types. So it's works, and often these kind of ideas are trying to be built on top of languages which didn't have these ideas. Sometimes quite awkward, the syntax and all that. So it may work, although it may be a bit weird and unusual. So I rather prefer the best tool for this specific task rather than using one language for everything. But good question. Thank you.
Yeah, thanks for sharing. Is there anyone here like not using the mainstream programming languages and want to share the experience on how you introduce it to the company?
Luke is not here, or otherwise he was.
Yeah, I mean, I can go first. I'm right now working in Berkeley as a front-end engineer, and recently I tried to same as Greg, we tried to introduce Elm to our company using Elm to create our front-end project, and now we have 3 of them out there. And the benefit of using Elm is it's much easier to learn for beginners. We don't have to know all the like functional programming concepts to start being productive. So yeah, it's really interesting. Anyone else?
Yeah, but I can have another information about M is, although the community is really in weird situation. So I mean, it's the only choice I have seen in the current marketplace of languages that provide a reactive loop already there with type system that nice enough. You can choose like okay other language, but sometimes it's lack of such reactive loop already there. So you need to write your own reactive loop, which is just the React.js is doing. Then you're wasting time to recreate your React.js. So M seems the only option, but unfortunately the community support seems somewhat few. So yeah, that's a pretty dilemma. Yeah. TypeScript, sometimes you get very serious problem with TypeScript, and of course all the Webpack tooling problem, all the dependencies that it cannot handle nicely, all the problems from Node.js as well. So it's not the language's fault. As I said, they have different goals. But why, at least my part, why I use M is because that's the only choice I can quickly make a prototype of a front-end project without spend time on writing tests to test something very trivial. I mean, and also you can debug the API actually, because you need to type out the API response and the request. I found actually API bugs when I was doing that. So that's another surprise usage for M. Yeah.
Nice. Thanks for sharing. Yeah, if there's no other one want to share, we can stop here for today. Thank you all for coming, and yeah, thank you Daisuke-san for the impressive talk. Yeah, thank you.